Okay, we're going to start with one from the packet. Can you guys hear me through the loudspeaker? Okay, good. All right. Number 51 is one from the packet. If you really haven't done this one yet, if you want to look at it with me now, I guess that'd be all right. I told you to put it away, but take it back out again if you want to. Number 51 is one on the yellow packet. Some kids asked me if I would talk about this one on the last video, so here we go. A square of side S is inscribed in a circle. All right, so here's a circle, and there's a square inscribed in it, which means it touches it at all four corners. And its side is S. Does that mean that the radius of the circle is 1/2 of S? No, it doesn't work that way. Okay, it'd be nice if it did, but the radius, if I go like this far, that's about how long 1/2 of S is. It doesn't go all the way to the edge. That wouldn't be right. So I have to do the area of the circle as a function of S. My first thought is, I've labeled this, but I have to figure out what the length of the radius of the circle is to be able to really label this well. So I need to know how big this is. Do you get what I'm saying? That's the radius of the circle from here into that corner where the corner of the square meets the edge of the circle. All right, so that distance right there. Well, I could do that by figuring out how long this whole distance here is and then cutting it in half, right? And then I'd be setting up a right triangle, and I've got sides that are S and S, and I could figure out how long this side is. What's the formula I use for that? Yep, A squared plus B squared equals C squared, and I know that the legs are S and S, so it's S squared plus S squared is equal to, I don't know how long C squared is, so I'll call it C. And then I put them together, and I say 2S squareds is equal to C squared. And now I got to get the C alone, and so I take the square root of both sides, square root of this, square root of that. It means the absolute value of C technically, but I don't want a negative side anyway. All right, so I leave it as plain old C is equal to the square root of 2S squared. That's how long this whole thing is right here. Square root of 2S squared. And then I want half of that, right? So the radius goes from here to here would be 1/2 of the square root of 2S squared. Or I could put all of this over 2. That's another way to say 1/2 of. All right, that was the hard part. Now the easy part. They want the area of the circle. Area of a circle is pi r squared. Area of this thing is pi, and then I just figured out r. What is it? 2s squared, square root of that, square root of 2s squared over 2. There's radius, squared. There's my answer. It's only got s's in the answer. Pi isn't the variable, it's 3.14. So I got my answer with only s's in it. That's a 2 down there. Okay? Now I could do the square root of s squared and get that out of there and make it a little more simple, but I think I'm just going to leave it the way it is. Yes? Okay, and that's the part I just said. If I wanted to take this s squared out from underneath the square root, I could, because, you know, I did the square root of s squared. And what would that make? Just an s. So if I simplify this a little farther, it'll probably be what the key said. Area equals pi, and I just said that I could do that square root of s squared and call it s. Okay, and then I still have to have the square root of 2 in there. And that's going to get squared, though, in a second, but okay, over 2. Do you get how that's the same thing as what I just wrote a second ago? All I did was replace the square root of s squared as s. Now, it's technically the absolute value of s, but again, we don't have to worry about that because we have a negative, can't have a negative side. So then, if I wanted to go even farther, I could go pi times, and that s can get squared now. No, wait, I took that out of the square root, sorry. And now that should be on the outside. Because I took it out of this, I've already squared it. It should be on the outside, sorry. And then I can keep going and then say the square root of 2 squared. Ooh, I can do that too. What's the square root of 2 times square root of 2? 2. So that's 2 over, and then I can square the 2. 2 squared is 4. So then area equals pi, and then I can put a 1/2 for the 2/4. And then I can put an s. It all depends on how far you want to simplify it down, and that is the best answer because it's simplified all the way. Is that the same thing as what the key said? Good. That is the right answer. Now, remember, it's a multiple choice test, the vast majority of it. Only a couple problems wouldn't be. So assume this is a multiple choice test. Well, and that wouldn't have been there. But this would have been there. And hopefully you'd have gone, okay, well, it's got a pi in it. It's got a 1/2 in it. It's kind of close. Oh, maybe I can simplify it farther, and then you would have simplified yours farther, and then you would have noticed that it's the same. I hope. Okay, moving on. Second kind of problem I want to talk about is number 53. The hypotenuse of a right triangle is 20. Okay, I'm going to draw my hypotenuse this way. Express the area of the triangle as a function of the length x of one of the legs. I'm going to call this one x. Now, if you think about it, if I call this one x, I can figure out how long this one is in terms of x by doing the little formula thing. A squared plus b squared equals c squared. A is going to be x, so that's x squared plus I don't know what squared is equal to 20 squared, which is 400. So then I go x squared plus I don't know what I should put squared has to equal 400. Now, if I'm trying to solve for the I don't know what to put squared, I'm going to subtract x squared from both sides. And then I have the I don't know what to put squared is equal to 400 minus x squared. And then I got to square root both sides. So I go square root of this is just question mark is equal to square root of all of that. All right. So now I just figured out that this side right there is the square root of 400 minus x squared. Now, that part is the hard part. Now the easy part. Express the area of the triangle as a function of the length of one of the x of one of the legs. Now I just got to do the area of the triangle. Area equals 1/2 pi r, no, it's a circle. 1/2 base times height. Base is right there. Area equals 1/2. Base is the square root of 400 minus x squared times the height, which is x. There we go. I know that's not easy, but it's doable if you know this formula, a squared, b squared, c squared, and you plug in this, this, and this, and you solve for the side you didn't know. I called it question mark. All right, next topic. What are 2 things to watch out for when you're determining a domain? Some people really get confused when it's like, what's the domain of this? And they're like, but what do I even do? Well, domain is the x's. The x's you can put in. Is there anything that would screw this up? No, so it's just all real numbers. So what are the 2 things you got to watch out for that could screw it up? Fractions. So if it's over something, now all of a sudden there is something that could screw it up, right? If I know it's -2. What's the other thing that could screw up? A square root. Let's say this whole thing was square rooted, like this. Now is there things that could screw it up? Yeah, if I get in like, this could be an important one now. Would -1 screw it up? No, but it's right on the edge. -1 makes it 0. And if I use like anything smaller than -1, like -2, all the way to negative infinity, it would screw it up. So where does it work? Well, where it doesn't work is from -1 back this way is where it doesn't work. So here's where it does work. And does it actually work at -1? Yes, it does. So how would I write that in interval notation? -1 to infinity. And that needs a bracket. Okay, so the things to watch out for in domain is don't let the square root become negative, and don't let the bottom become 0. All right, next topic. There's 4 kinds of limits. We haven't talked about limits in a while. Do you remember when there's asymptotes like this, and you got a graph that, let's say, goes like that, let's say there's asymptotes going this way too. And let's say that the other part of the graph goes like this. How to write the 4 different kinds of limits? All right, let's say that this is at 0, and this red one is at 3. Would you write me the limits, all 4 of them? There's the limits for the left end, limits for the way right end, and limits in between. See if you know what I'm talking about. And hit pause while you try that. Okay, for those that are having trouble starting, here's how the limits always look. Limit of the function as x approaches, well, that and this next number kind of depends. And there's always an equal sign there. And the only things you got to fill in is something goes here, it's the x number, and something goes there, and it's the y number. And a lot of times you use infinities or negative infinities, or sometimes you use regular numbers. All right, the way left end would be, if I go way this way, I would be where x is what? What's the x part down here? Negative infinity. Okay. If x is negative infinity, I've gone way this way. And what would y be? Well, it's pretty much at the green line, which I said was at 0. So it's hovering right above that axis there. So it would be, when I really go way this way, I'll get to y is 0. Raise your hand if you had that one on your paper. All right, good. The right end, I'll put it on the right, logically, is limit as x approaches positive infinity of the function is, and again, the highest it ever goes to is 0. That's the y value of it. The x value would be way, way, way over here. And so the y of it would be getting close to the dotted line, which is at 0. Okay, and now how about the limits in here? This limit right there. Somebody raise your hand and tell me what you think that one was. Be confident. You can do this. Yes, girl's been gone for a week. Limit of the function. X approaches 3, perfect, because that's here. That's where it's approaching this spot right there from the, excellent. Very good. Did anybody have that one right? Several people. About half the class. A little more than half the class. All right, and now this part of it right here. Those of you that got the other part right, you must be more confident now. Somebody else tell me. This one. Come on, show me you're not afraid. Yes. From the positives, yes. You are correct. Nice job. So there's 4 kinds of limits you can write. The ones that are approaching the vertical asymptote are these 2. These are the ones that are the ones approaching the asymptote. The other 2 are end value limits, like way on the right and way on the left. There's several limit questions. Are there any questions that you have about limits? Yes. Not on one problem. Well, actually, there could be. There could be on more than 4 if there's more vertical asymptotes. So, like, let's say that the function did this. Let's say it's like one of these weird ones where it passes through the asymptote, which is rare but happens. And let's say there's one like this. There's part of it like this. Now there's a limit way on the left end and way on the right end. But now there's 4 more than that, so there'd be 6 limits on this one. Yes, sir. Increasing and decreasing. I did cover that on one of the other videos, but I'll cover it very briefly here. Where it's increasing is where you're looking at the graph and it is rising as you go from left to right. In this particular graph I just drew, it's never rising. Isn't that weird? Because as I read from left to right, it's always falling. So on this one, where is it rising or increasing? As you read from, left to right, it's never increasing, but it is sometimes decreasing. In fact, it's always decreasing as I read from left to right. Okay, so this one would be decreasing everywhere. Although, I don't know if you'd have to not include the asymptotes. We don't usually do it on this kind of a problem. Usually we'd have them like this. And there's a graph like this. Boing. And then we'd say, oh, it's decreasing from there to there. And that spot's at like -3, 0, and this spot's at like 2, -5. Do you know which numbers to use, the x's or the y's, to tell me it's decreasing from there to there? Yes. So we'd say from -3 to 2, it was decreasing. All right. That's decreasing, increasing. All right, next topic. We just finished up and had a test on this stuff. Remember this? You make a sign chart. You figure out what numbers to put on the sign chart. And then from the sign chart, you can try to figure out whether the actual answer works. Would you please try this one? If you understand how to do these, it'll take you less than a minute. Make me a sign chart for this puppy. And then tell me where the final answer is. Okay, hopefully you've figured out that there's a few important spots along here. Let's pick this one. Does that tell me an important spot? Yep, it tells me -5. -5 is important. Does -5 work? No, it's an asymptote. So it's at that spot there's an asymptote line. Okay, so it's actually undefined. I might start you doing like a little thingy like this above it, meaning that it doesn't actually work there. Okay, how about at the 2? Is that an important spot? Yeah, I'm skipping one though. -2 is the next one I should probably put. That's for this. And then there's +2. That's an important spot too. The -2 is what's going to make that one 0. Will that one work or not work? It works. Now the way I've been doing that is I put a solid dot there. Okay, because it's a 0 that works. Now in Mrs. Richard's class, I think she would have put a solid dot there too. But even if it hadn't been or equal to, she still would have put a solid dot there. But so we do our dots a little bit differently. As I was looking at the final, I think the main point is that you know how to write the answers, not how you make the sign charts. Okay, so then the final thing is 2. 2 doesn't work because it's an asymptote empty spot. Then hopefully you checked in between each one. Is there anybody that's pretty confident that theirs are right? Just, all right. Yes, sir. Can anybody verify that? If they got the same thing? And that seems to be most of the kids. All right, so that's probably correct. So then, just to show how to check one in case you're at home a little lost on how we just did that, if I tested 0, it's in between here and here. I put in a 0 here and here and here, and I see what happens. And 0 plus 2 squared is positive over 0 plus 5 is positive, and 0 minus 2 is negative, and that's one negative and a couple positives makes overall it's a negative answer. All right, good. That's how you check those. Then I'm looking for places where the function is less than or equal to 0, which would be this spot and this spot. Now, how do you write that? Well, it starts at -5, right? But what does it go to? +2. Why don't you even mention the -2? Because this still works. And it keeps working all the way through there until you hit +2. So there's your final answer. If you broke that up into 2 parts, I'm not sure it would even be considered right. But it's a multiple choice test. And if they had this on there, I'd pick it. If they had this on there, -5 to -2, and in parentheses, and then having it work there, union with -2, I don't think we're going to see that because that would just confuse things because it's kind of right, but it's not the way you normally write them. So I wouldn't want to do that. I'd do that. Okay, any other questions on this? Okay, moving on. Next topic. Do you remember how to solve that? If I want to get x alone, what's the first thing I'd want to do? Square both sides. First of all, if there'd been like a 2 here, I'd want to get that to the other side first. Got to get the square root alone. Once the square root's alone, then I can square root to fix it. Or sorry, square to fix it. If I square this, and I square that. All right, now, the squaring it makes it x plus 5. But here's where a lot of people take a shortcut and think, oh, it's just x squared plus 1. Nope. It's really x plus 1, x plus 1. And that makes x squared plus 2x plus 1. And now I got to solve this puppy. And now I got to get everything onto one side. I'm going to say 0 equals, get this over there and get that over there. X squared. When I take away x from both sides, I'll have just 1x left. And then that over there is taking away 5. And I had positive 1 minus 5 is negative 4. And then if I can factor that, or if I can solve it with quadratic formula, or since you have a calculator, you could graph it. But anyway, that's how you finish it. Just remember realizing it's a quadratic. All right, any questions on that kind? Okay. Then we have come to the end of the internet. So you do not have, if you go and watch the other videos, there are some good things on there, I'm telling you. I just can't cover it all during our class. So watch the other 2 parts. This was the 3rd part and the final part for today. If you were here today in one of my 3 classes, go watch the other 2 videos. All right. Good luck on that final.